Today we're going to get started with our exponent unit. And with our exponent unit, we are going to be simplifying problems, as you can see here, with exponents in them. And we have a bunch of different properties that we use to kind of help us out. The first one that we're going to talk about is the multiplication property. Now, the multiplication property says that if we have the same exact base in two problems, so notice here I used b as my base, and I used n and m as my exponents. Now, if we have the same exact base, when we're multiplying exponents, we can actually add those exponents together to simplify it. Now, I'm going to show you an example over here. Let's say we have 4 to the second power times 4 to the fourth power. So when we have a problem like this, how did I get to adding the exponents from before? Well, I am going to show you how to write it out in expanded form. If you remember expanded form versus exponential form like it's written in from last unit, 4 to the second power can actually be written as 4 times 4, and 4 to the fourth power can be written as 4 times 4 times 4 times 4. Okay, if you remember that from last unit. Now, the definition for multiplication property said to add. Well, if we were to do this problem to add the exponents, we'd get 4 to the 6th, right? Because 4 plus this 2 here, we'd get 6. Now, how did we get 6? Notice in our expanded form, we have 1, 2, 3, 4, 5, 6 4s. Okay, so either way, if we were to write it out in expanded form or use our multiplication property shortcut, we get 4 to the 6th power. Okay, so I'm going to show you the multiplication property in these next few examples here. And I want you to kind of remember that you can still go back to this expanded form if you're ever unsure. So this first example here, we have 8 to the third times 8 to the fourth. Okay, notice we have the same base of 8. So that means we can use the multiplication property, which says if they have the same base, we can add the exponents when we're multiplying. So I have 8, and I'm going to add 3 and 4 together. So I get 8 to the 7th power as my answer here. Now again, we could write this out in expanded form. We could take 8 times 8 times 8, and then times 8 times 8 times 8 times 8 again. And we still get 1, 2, 3, 4, 5, 6, 7, 8 to the 7th power. Example 2. We have 5 to the 6th times 5 to the 2nd, same base, and I'm going to put 2 together, so I get 5 to the 8th power when I add them together. Now, if you notice down here, in these other ones, we have kind of a little different situation going on. We have letters and numbers going on, and we have kind of a variety of different bases. So here, notice that we still have a base with our exponents. So if we're looking at our exponents, we have x to the second and we have x to the fourth. Okay, so when we have x to the second times x to the fourth like that, we can still use our multiplication property with our x's. So I can add those exponents, 2 plus 4, so I get x to the 6th. Now, I haven't forgotten about the numbers out in front. Okay, when we have these numbers out in front like this, okay, we can just do regular multiplication. Okay, so when I have 2 and 3, okay, well, elementary, 2 times 3, we get 6. Okay, so I have 6, and I also have x to the 6th that I found up here. So all we have to do is put them together. Okay, and we typically put the number out in front of the number with the exponent. Okay, so let's do that again. Here we have 6 times x to the third times 2 times x to the 5th. Okay, so here I'm going to take x to the third times x to the fifth and do my multiplication property shortcut, which I'm going to add those together, 3 and 5, to get 8. And then we just take our 6 and our 2. We multiply them together to get 12. So my final answer is 12 times x to the 8th power. Okay, now if I were to write that out in expanded form, okay, I want to show you an example of this one so that you can still see that we'll get 12 times x to the 8th. So if I were to write out this in expanded, I have 6 times x times x times x times 2, and then I'm going to have 5 x's written out. Okay, well notice if we were to just do regular multiplication, I still get my 6 times 2 to get my 12. And then if I add 1, 2, 3, 4, 5, 6, 7, 8, I get my x to the 8th power. Okay, so you can always go back to that expanded form if you're ever unsure. All right, I'm going to do these next couple too because I just want to make sure everybody is on the same page here. So for this next one, 5 times x to the third times 7 times x to the fourth, I'm going to multiply my x's together because they have the same base. And now when we multiply, we add the exponents. So I get x to the 7th. And then here I have my 5 and my 7 together. And when I multiply those numbers, we get 35. So I get 35 times x to the 7th as my final answer. This next one, hopefully it doesn't trick anybody up because we have different bases this time. Notice we have a to the 7th times x to the 6th. So notice that we can't use our multiplication property shortcut for this one. Okay, so this is actually simplified. Okay, I can't do any combining, but I can combine my 10 and my 4 that were out in front to 40. So my final answer here, I just leave it the 40 and then leave this a to the 7th and x to the 6th power because I can't combine those because they don't have the same base. One's an a and one's an x. It doesn't work. Okay, I want you to do these next 4, and if you're still having questions on it, please make sure you're asking your teacher or somebody next to you.